We are finishing the booklet that we started yesterday. We have got the last 2 pages to do. So here we go. Solve and be sure to check for extraneous solutions. Let's look at the first one. Now I need you to understand there are different ways we can do this. Well, let's think about it. How many fractions do you see on the left side of the equal sign? 1. And how many on the right side? And when you have 1 fraction on each side, what's the easiest way to do it? Cross multiply. So let's cross multiply. If we cross multiply, we're going to have z squared minus 4z, good, equals z squared plus z. What are we going to do? Okay, we're going to make it set it equal to 0. How are we going to set it equal to 0? You want to move the left side to the right side. Fine. So if we subtract z squared from both sides, let's do this one step at a time. I have a reason for that. What do we get? What do I get? Negative 4z equals, keep moving. We still want to set this equal to 0. Add 4z to both sides. And if we add 4z to both sides, what do we get? I get 0 equals 5z. How do I get the z by itself? Z equals 0. That's a reason. Check it. If z is 0, what's this fraction? 0 over, what is 0 divided by 1? 0. Yeah, so 0 divided by 1 is 0. What's this if z is 0? 0 divided by negative 4 is 0. So I get 0 equals 0. Therefore, my solution is a good one. Number 2, or B. What do you say about B? Yeah, can I cross multiply? No, because I have 2 fractions on the left side of the equal sign. Yeah, that's my common denominator, x. So, yeah. So now let's see what we've got. I've got x squared over x plus 8 over x equals, can I add these 2 fractions now? So I've got x squared plus 8 over x equals, questions so far? Now listen to me. On this one, there are a couple ways you could do it, but one's definitely easier than the other. You could cross multiply because you got 1 fraction on each side of the equal sign. But do you see that your denominators are equal to each other already? Well, if those fractions have to be equal and the denominators are already equal, then the numerators have to be equal. So let's just take the numerators and set them equal to each other. Good, because we've got a quadratic, degree 2. We're going to set this thing equal to 0. Honey, I don't have a minus 5x. forget this right now. So what's x equal to? X is equal to 4 or 2? Well, we got to check, dadgummit. Austin says they both work. If x is 4, then this is 4 plus 2 equals 6. Great. If x is 2, then I get 2 plus 4. Way to go. No. Right. If one doesn't work, it means that one doesn't work, and that's all it means. All right, C. What do you want to do about C? Indeed, I want to solve it. How? 2x is my common denominator. Okay, I'll buy that. First fraction. What do I need to do to it? Anything? Multiply by 2. Second fraction, 4 over 1. I need to multiply that sucker by 2x. And the third one, leave it alone because it's already got a 2x in the denominator. So let's see what in the world I've got. I've got 2 over 2x plus 8x over 2x equals 10 over 2x. Now, left side. I have common denominators, right? So I can add them. So 2 plus 8x over 2x equals 10 over 2x. Now, Giselle said we could do the same thing as before. If two fractions are equal, their numerators are the same and the denominators are the same. What do you see about the denominators? They're the same already, so what do I know about the numerators? They have to be the same, so I'm going to set them equal to each other. Question? Well, I don't know. What did I do? No? No? Life is good. 2 plus 8x equals 10. Now, some of you are able to look at that and you're able to know right away that x is 1. Totally fine. Is x equal 1 an okay answer? Well, I don't know. If x is 1, what's this? Plus 4, and that would be 10 divided by 2. Life is good. X equal 1. One more on this page. Okay. Who's out there? Okay. Do you need to factor anything? No. So what's our common denominator? X minus 7 times 2. X minus 7 times 2. What does this first fraction need? So I'm going to multiply top and bottom here by 2. What does this need? This needs x minus 7. And then I'll go to a different color. That one needs 2. Okay. On the left, so this doesn't get too messy, on the left I've got common denominators now. So I can just add the numerators, correct? So what is my numerator going to be? Hang on. 4x minus 18. Now this is a plus. X squared minus 7x all over 2 times x minus 7 equals 10 over 2 times x minus 7. What do you think we should do now? Combine like terms. We've got like terms we can combine. X squared minus 3x minus 18 equals 10. Why did I leave off the denominators? Because they're the same, so the numerators have to be the same. Well, no, yeah, subtract 10. Good. Oh, daggum. Minus 3x minus 28 equals 0. Now factor it. How's this factor? I heard x plus 4 times x minus 7. Is that right? Any problems? Oh, got a problem. X cannot equal 7. Good luck. Can x equal negative 4? Where'd I put my eraser? Yeah, it does not make a denominator equal to 0, so I'm okay. We're halfway through. That's pretty good. Last page. Left, or E. I could cross multiply if I want to, because I've got one fraction on each side. But the denominators are already the same, so the top has to be the same. Which is easier? You want to just let the numerators equal since the denominators are already the same? Subtract 2x, what am I going to be left with? Which does not work because what does it do? Makes the denominator 0, which makes the fractions undefined. Undefined. So you're going to say, no, say no solution. There is not a solution. F. I got a dot. I've got a difference of 2 squares. A squared minus 1. What does my first fraction, back up. What's my common denominator? A minus 1 times A plus 1, good. So what's my first fraction need? A plus 1, good. Good. Second fraction needs A minus 1. That's really bad. A minus 1, that's even worse. You know that's A minus 1, okay. Fraction on the right side, pretend it's A minus 1. Here, fiddle. A minus 1. The fraction on the right side, does it need anything? No, it's already got A minus 1 times A plus 1. Now my denominator on the left is, okay, let's see what we got. What's this? That's a plus, so 4A. Combine like terms. What do I see about the denominators? So they're the same, so set the numerators are equal. So let's combine like terms and set the numerators equal to each other at the same time. 5A. Can you do that in your head? I know Dawson can. 2. Yeah, A is 2. Now, does this make anything undefined? Nope. Good answer. Good answer. Guys, you're doing well. It's quiet. Okay. Two more. Here we go. G. What are we going to do? G for Giselle. What are we going to do? We've got a denominator we need to factor. How's that factor? Well, you guessed right. What's this first fraction need? It needs x minus 3. What does the second fraction need? It's already got x minus 3 times x plus 1. And this one needs all right, left side of the equation. Left side. What have I got in the numerator? 5x minus 15. Now, question. See if you can think ahead a little bit. What are my denominators going to be? The same, right? So if the denominators are going to be the same, just, well, yes, but what do I know about the numerators? So just set the numerators equal to each other. Equals 6x So I got 5x minus 15 equals 7x plus 1. Okay? What are we going to do? Subtract 1. What else? Subtract 5x. So if you want to subtract 5x from both sides, that'll give me negative 15 equals subtract 1. Right. If I subtract 1, I get, and then, so x equals negative 8. Is that okay? Can x be negative 8? Does that make any denominator 0? Nope. Life is good. One more. Dang, look what time it is. Dang. Here we go. What about this one? Last one. What do we want to factor? Okay, let's think about this. Do we need to factor the numerator? We need to factor the numerator if there would be a common factor in the numerator and denominator that I could cancel out. Will that happen? No, that's not going to happen. So all I would do here is I would deal with this minus right here and then go get a common denominator. So let's do this. Let's write x plus 1 over x equals, now if I make that a plus, what's going to happen? All of them are going to change sign because I'm going to distribute a negative 1. Negative x squared plus 3x plus 4 over 4x. And I really do think you will make fewer mistakes if you deal with that negative or the minus up front, okay? What is your common denominator? 4x, good. What does the fraction on the left need? Now you be careful here, you got to multiply that whole thing by 4. What does the 1 over 1 need? It needs a 4x. What's the last fraction need? Nothing. Nothing. It'll be 4x over 4x. Mm-hmm. Yeah, 4x over 4x simplifies to 1, which it should. I've got the same denominator. What do I do? Well, what do I worry about? Make what equal each other? The numerators. All right, here we go. What's the first numerator? 4x plus 4 equals 4x plus, I'm going to because I have like terms, so yes, I'm going to. 4x plus 4 equals negative x squared plus 7x plus 4. Why do I want to move the x squared to the left? To make the x squared term be positive. So we're moving everything to the left. That left. Okay. Can you do that in your head? Add x squared. Add x squared. Right? Takes care of that. What do I do with that 7x? Subtract 7x. So that'll be a minus 3x. And minus 4. Oh, that's 0. Oh, because x is a what? It's a GCF. There you go. Yeah, it's a GCF. X times x minus 3. Zero or 3. Why can't x equal 0? Oh, because it would make this and this be 0, so it would make two fractions undefined. Can x equal 3? Yes. So x equal 3. Ladies and gentlemen, do you feel like you understand what you're doing on solving equations with rational expressions? All right, now I'm going to give you a pink sheet to do, and I'll take the answer key down there with us, and we'll just go to the back courtyard. Let's see.